Fantastic. Well, welcome to session 2, which is on policies and approaches to embodied decarbonisation, excuse me. And our first speaker is Dr. Arman Azari, who's of course the chair of the symposium and associate professor at Penn State University in the US. Thank you.
Thank you very much, Alice. So I'm going to share my screen and all right. Okay, so very good. So thank you very much, everyone. The research I'm presenting today is a part of the research projects in Resource and Energy Efficiency Lab at Penn State, RE2 lab. The lab consists of 1 core faculty, 3 PhD and 2 master's students, as well as multiple affiliate faculty and collaborators. And we do research in 3 themes of multi-scalar assessment of environmental impacts of buildings, building skins with energy generation, and carbon capturing or the carbon removal capabilities, and hybrid modeling of urban environmental sustainabilities. And you can find the logos of the current and past sponsors, without whom we were not able to do our research. So we would like to appreciate their contribution as well. I usually use this slide that is borrowed from the NASA website in my presentations to communicate what motivates my research, and that is basically the urgency to address the high levels of CO2 concentrations in the atmosphere, which presents a significant challenge to humanity. This diagram tells us that for hundreds of thousands of years before 1950s, the maximum CO2 level in the atmosphere was 300 particles per million, but we reached a 416 particle per million level in 2021, which is well above 350 that is considered to be safe limit. I checked the NASA website last night, and their latest recording of the CO2 levels is for October 2022, and that is 419 particle per million. So in other words, in less than a year, 3 ppm has been added to the concentration of CO2 in the atmosphere. Speaking about the percentages, in this presentation, I'm going to present an overview of energy use and greenhouse gas emission contributions in the United States and its national drivers, and some of the policies to limit global warming below 1.5 degrees Celsius. The United States is the second largest emitter of GHG emissions, with a share of 12.67% of global emissions. The most recent data shows that the country's annual energy use is 98 quadrillion BTU, which is about 103 exajoule. 39% of total energy use in the US goes to building operation, with at least 6% that goes into building material manufacturing and construction. These figures include electricity use and its loss in the system. The United States also emitted about 5.98 billion metric tons of equivalent CO2 emissions in 2021, 20% of which is caused by direct and indirect emissions related to building operation, and at least 6% of which is caused by building material manufacturing, particularly cement, steel, and aluminum. So in the building sector, the residential is the largest consumer of energy with a share of 21%. 72% of residential energy is consumed for space heating and cooling, followed by 22% of plug loads. In commercial sector, the share is 18% of total energy use in the US, and the energy is primarily used for for 40% of that is used for heating and cooling, followed by 42% plug loads. The energy consumption of the residential sector is directly driven by 3 factors, including population, size of housing units, particularly floor space, and household size. US population has increased by 12% since 2005, and 2005 was the year that we had the largest GHG emissions. Also, as more Americans tend to live alone, the household size is shrinking, leading to a 2.33 decrease in 2021, yet the average size of new housing units has increased by 1.89% compared to 2005. Despite directions of these trends, as well as increase in the floor space of both residential and commercial floor space in the United States, both energy use and GHG emissions of the building sector has fallen in 2021 as compared with 2005, and with a 3% decline basically in the energy consumption of residential sector and more than 2% reduction in commercial sector. While part of this trend is certainly because of the effects of the pandemic, energy efficiency improvements, electrification, as well as decarbonization of electricity sector has contributed to this decline. Acknowledging the need to limit global warming to 1.5 degrees Celsius, the United States government has defined 3 targets in its effort to control its GHG emissions, including 26 to 28% reduction of emissions in 2025, 50 to 52% reduction in 2030, and achieving net zero emissions status in 2050. Building decarbonization is at the core to achieve these targets. Currently, fossil fuels provide about a third of total energy use in the building sector in the United States. Also, about 2/3 of total energy use in buildings is because of electricity use and the loss of the electricity in the system because of transmission and other factors. Renewables only account for 3% of energy use in buildings. Therefore, further improvement of building energy efficiency when combined with electrification, in particular decarbonization of the electricity sector and the renewables, presents significant potential to achieve the net zero emission status in 2050. So there is a strong focus, particularly to electrification of the buildings and also to generating basically carbon neutral electricity based on the strategies of the government. The new long-term strategies of the US government also focuses on reducing the embodied carbon emissions. Currently, at the global scale, embodied carbon represents 28% of the building emissions annually, as compared with 72% share of direct and indirect building operational emissions. But it is estimated that building construction globally between now and 2050 would account for about 50% of building emissions. This shows, of course, the urgency to focus on embodied carbon. The embodied carbon strategies in the United States are pursued by regulations and policies at federal, state, and local levels. At the federal level, the Federal Sustainability Plan and President Biden's Executive Order 14057 sets the target for all federal buildings to reach net zero emission status by 2045, with 40% reduction of emissions by 2030. The government also defines new standards for low embodied carbon concrete and requires all federal contractors to disclose environmental product declarations of their products and embodied carbon, of course, for materials used in new building projects. At the state level, currently 8 states have passed laws or are in the process of establishing procurement policies that would require environmental product declarations and limiting of embodied carbon for major the construction materials and in particular concrete, glass, and steel. At the local level, more than 25 cities and authorities in the United States have climate action plans with embodied carbon implications. Embodied carbon reporting and improvement are also actively pursued through green building rating systems such as LEED and Living Building Challenge. An important next step perhaps would be to include mandatory embodied carbon targets and thresholds in the building codes for the United States buildings. The size and trends of the building construction industry in the United States shows both the urgency and opportunities for change. To better understand these opportunities, we have used the trends of population growth and variations in the sizes of commercial and residential stock to provide a simple estimation of the new building construction by 2050 in the United States. The existing building stock in the United States includes 24.6 billion square meter of residential floor space, 9.2 billion square meters of the commercial, and 1 billion square meter of industrial building sector. We estimated that a total of 9.7 billion square meter of new building construction will be added to the existing stock by 2050. That is more than 12 times the area that is covered by the New York City. A knowledge gap in the field of embodied carbon is a lack of tools to help policymakers understand the magnitude of embodied carbon implications of building construction at the scales of urban, regional, and national levels. In a project entitled URBEC, Urban Embodied Carbon, we aim to integrate bottom-up and top-down modeling approaches to create a tool that helps understand how current and future construction practices and embodied carbon policies would affect the United States goals to achieve net zero emission status by 2050. In that direction, we are developing frameworks and models to quantify, assess, and predict embodied carbon at regional and national levels under different scenarios of growth, densification, and decarbonization policies. In the first phase of this project, we focus on estimation of embodied carbon of residential building construction at the national scale by 2050. We used clustering analysis and identified the share of different archetypes of residential buildings in the US construction industry based on the type of building, structural materials used, and the main cladding materials. As an example, the existing data shows us that the new single-family housing in the United States has a 98.8% share in the residential construction market based on the number of buildings, and a share of 84% based on the floor area. Wood framing represents 92% of single-family housing construction, and concrete framing represents 8%. We used the results to create 30 combinations of building design that would represent the residential construction in the US and determined the share of each combination in the total market. For example, the share of single-family housing unit with wood framing and brick cladding was determined to be 14.6% of the entire new housing construction market in the United States. In the next stage, we used drawings and bills of materials for 2 actual projects to create BOM for 30 combinations and used Athena Impact Estimator. And this is a tool that is used primarily for the North American construction market to model the embodied carbon and life cycle environmental impacts of these 30 combinations. We then aggregated the results to estimate the embodied carbon of the new buildings to be built by 2050 based on the projected growth on population and the projected growth in residential stock. So through this research, we were able to develop a framework to estimate the embodied carbon and life cycle environmental impacts of the building construction industry at the macro level of a country. The results of our analysis showed that if we continue with the current growth of the housing stock, basically 2.7 billion square meter of housing is added every year to the US construction market. So with the current growth that has been going on for the past decades, probably we can't achieve the new targets of net zero emission status by 2050. The contribution of our work is primarily a framework to estimate the embodied carbon at larger scales beyond buildings. The advantage of this method is also that it isolates the effects of different archetypes of building construction on GHG emissions of construction industry based on type and the share in the market. The results also help understand the effects of embodied carbon policies on controlling US GHG emissions. In the next step of our research, we are accounting for the trade-offs between operational and embodied carbon. We are adjusting the model for regional sensitivity. We are trying to provide further clustering in order to classify buildings based on more parameters, but of course, the availability of data is a challenge for us. We are trying to adjust this model to also work for commercial buildings of different types to be included. And finally, we are now working to test this model for New York City. New York City is the 86 million, if I remember correctly, 86 million square meter of housing is added every year to New York City. So there's a great potential for improving embodied carbon in major cities such as New York. So that concludes my presentation, and I would be happy to answer any questions that you might have.
Could I ask if there are any questions? I can't see any in the Q&A. Sorry, Ming, you have one. You say, can you talk a little more about what rates, attributes and parameters you use to estimate the building stock growth till 2050? Do all states and jurisdiction have the same growth rate? Are those all new construction or also major renovations?
So we used the American Housing Survey data as well as the US Census Bureau data, which shows the steady growth of the pretty much in the past the few decades. There has been a steady growth of the residential housing markets. There are some research that show that there is a famous paper published that shows 120 years of housing market, how it has changed in the United States. So we use some of the assumptions based on that the article as well, and use that to project the growth by 2050, assuming basically a linear growth by 2050.
Brilliant, thank you very much. I can't see any other questions in the Q&A, but I have a number myself, Raman, which I won't attack you with just now. But I was particularly interested to see the high percentage of single family buildings in your residential buildings. And that's obviously very different to most of Europe. I wonder if your modelling suggests that providing more multi-family buildings would be a lower embodied carbon solution.
We are considering the effects of different models of growth for the housing market, and one of those currently 16% of the based on the floor area, 16% of the entire housing market belongs to multifamily. So we are modeling the potential increase in these percentages from 16% to 30% and to 50%, and how that would impact the embodied carbon.
That's brilliant. Thank you very much. I look forward to reading your paper.
Thank you.
Okay, thank you. So we are now on to our second presentation, which is by my other fellow co-host, Freya Nygaard Rasmussen. And Freya has actually just started, I think this is right, is it, Freya, an associate professorship at the National Technical University of Norway. So welcome, Freya.
Thank you, Alice. Well, actually, no, I am a postdoc at Aalborg University, but only for a couple of days. Still, and then I'll be with NTNU in Trondheim, Norway. Yes, so I have the honor of presenting to you some work I've been involved with about regulation in Denmark, upcoming regulation about embodied carbon in the building regulation. And now I think you don't see it in presentation mode, am I right?
Yeah, not yet, but at least we don't see your notes.
Just because I don't have any.
Okay.
Well, where's the?
Is that, yeah, there's a button down there usually. That's good, great.
Okay. I have to get rid of a few boxes here. Okay, yes. So I will take you on a brief tour through the embodied carbon in building regulation that we have established in the Nordic countries in Europe, Finland, Sweden, and Denmark as an example, but other countries are also moving ahead quite fast in Europe. For instance, in France, and it's been implemented, and in the Netherlands, it's been for several years now. So this is just and the contribution we have for the handbook here is an example of how it was implemented here in the Nordic region. And then this, okay. So you know these numbers, you've seen them before. We know that the built environment is associated with resource consumption and excessive energy use, and we need to make sure that the stakeholders involved in the building industry make the right decisions in lowering the greenhouse gas emissions associated with the whole life cycle of the building. Now, this has been on the mind for policymakers in the Nordic regions for a while now. And recently they have taken it up a notch by really having this whole focus moving from a voluntary exercise by the industry stakeholders to a mandatory exercise. Because in the Nordic region, there's been several green building certification schemes in use, and the industry has gradually moved into using these sustainability assessment schemes as a way of promoting their buildings and building up competencies within the area. But the authorities in the Nordic regions have also taken it up a notch by moving from the operational perspective to including embodied emissions and also whole life carbon emissions. So it's not just focused on the emissions associated with the operational, but also the embodied. And that's also a step for the industry, of course. Some of the external drivers for this development that we've had here is partly because of the industry gaining more and more experience with it and having input from a growing research field within the area. It's also the national or the regional regulation that we find from an EU perspective. So we have sorry about the abbreviations here for non-Europeans, but we have the Energy Performance in Buildings Directive, which makes every country in Europe, we have to consider the energy, operational energy use in buildings. And now it's also lining up for the inclusion of whole life carbon calculations, documentations, as within a few years that will be part of the EPBD. Then we also have the construction product regulation, which is a regulation about how to market construction products. In the recasted version of that, there'll also be some requirements on documenting the environmental performance of the products. So it's a lot of different regulation is moving into that direction. We also have the financial regulation about a new established taxonomy, where financial institutions and large businesses must comply with some taxonomy rules when reporting their activities in order to promote sustainable financial activities. One of the more sort of specific initiatives from the Commission is also preparing the level scheme, which is a reporting scheme for sustainable buildings. So it's in the area as the sustainable building rating systems that we know from before, but now it's also from the European Commission side pushed from there. So this is all driving in the direction of the Nordic countries wanting to take up embodied carbon as part of the regulation. So it doesn't, as I've been trying to outline here, it doesn't come out of nowhere. And this figure here below is trying to outline what came before in the countries here. Above the timeline here, you see for Finland, Sweden, and Denmark, the political deals made in the countries and the political targets about carbon neutrality. We basically have the whole palette of words here carbon neutral, carbon negative for the Finnish example. For the Swedish, they are aiming for net zero and net negative. And in the Danish climate law, it's aiming for 70% carbon emission reductions in 2030 and then climate neutral in 2050. So all the carbon climate negative zero we can have in one figure here, basically. So this is sort of the more general national acts about climate and emission reductions. And then moving on to the building level, the construction industry. Finland has launched a requirement about climate declaration for new buildings and a plan for introducing limit values that will be gradually lowered. Sweden has also already introduced the declaration, the mandatory declaration, and there will be limit values introduced as well. In Denmark, we have the declaration enforced from the new year, and there we already have limit values in this version of the regulation, and then they will also be gradually lowered. So there's a lot there's a lot of supporting political initiatives for the focus on construction. It's not so the message is that it's not just about the construction industry being regulated. It's in a broader political perspective. This should be seen as part of. Just as an example of what it is to be on the research side of it, from my Danish perspective. So this is sort of the what do you call it? The symbiosis we've had until recently in establishing life cycle assessment-based methods for evaluating buildings. We've also produced freely accessible tools that the building industry could use and obtain new knowledge. And then they would ask for product data that we could again feed into refining the method. And we would have such a nice sift around, and we would publish some reports and some papers. But then when the politicians came onto this and started putting it into the regulation, we were really excited from the research side, of course, but it also really fired up the demand for all the other things we have here in this circle of LCA life. So all of a sudden there was a growing demand for product data. There was an increasing pressure on the credibility of the method. Can you prove that it is like that? What about the scenarios that you introduce? Like much more focus on the credibility, perhaps not surprisingly. And then the introduction of limit values also really put a pressure on the way that we handle the data and the method, because it has to be, because when we deal with limit values, and in Denmark, they put limit values for 12 kilograms of CO2 equivalent per square meter per year. When everyone building a new building for this limit value now, it's only for buildings more than 1,000 square meters, but still, that's a lot of buildings in Denmark that has to comply with these limit values. Then the whole setup around the data that you use and the method and the tool has to be airtight, and it has to be locked in the whole period that this version of the regulation will be in place. So it's a lot of pressure to put on a method, and I wouldn't say that our method is immature, but we had hoped to kind of gradually refine it on the way, but we cannot do that. We're not allowed to, because the policymakers has already drawn the line here. Okay, let's aim for 12 kilograms of CO2. So they say, oh, it's fine. You can mess around with the method and improve as much as you like, as long as you don't touch the data behind these 12 kilograms of CO2 that we have set as a limit. And then we basically can't do anything from a research point of view. So now we're basically locked into these 2 years of method, data, and tool. But it will be very interesting to follow also from a research perspective, of course. Anyway, the method, the data, and these limit values, the benchmarks that we use, they're quite crucial in the combination that they make, or in the configuration they have. So I'll dive a bit more into that to show you the differences in the Nordic countries, because on a superficial level, all the Nordic countries, they look alike. Even the flags look somewhat different, somewhat similar. But even though the Council of Nordic Ministers, they have had several working groups and workshops about how we harmonize this LCA method for the construction industry, because a lot of businesses operate across borders in the Nordic region, of course, it hasn't been possible at all to sort of make that harmonized method. So that's interesting. And a lot of it is based on how the local building industries used to do things in the way they ran their sustainability assessment schemes, the voluntary ones. So you see here, just from the scope of the different regulations, we have different units of comparison here. The Finnish regulation measures of per heated floor area, and the Swedish per gross floor area, and the Danish has an inexplicable hybrid unit that deals with 25% of the balconies and some percentage of the basement as well. Just a copy of the energy regulations in Denmark, so as not to confuse practitioners even more. So they only have to look into one place when they write in the square meters in the schemes, but very difficult to explain to outsiders. That's why I'm just calling it a hybrid unit. That was the unit of comparison, and then you see how different the life cycle modules are taken into account, reflecting the focus areas that the different countries have had. For instance, the Finnish looking very much into the development of the levels scheme I talked about before from a European level, and the Swedish industry looking more into or emphasizing more the upfront emissions for the certainty aspect. We know this will happen within the next couple of years, to kind of put focus on that. And then we also see from the inventory it's supposed to be included is quite different. This is illustrated here at the bottom, where the Finnish is quite comprehensive with the groundworks and foundations and shell, building shell and inner fittings and systems, whereas the Swedish for now is just the shell and the partition walls. And the Danish is almost as comprehensive as the Finnish. But for all of these regulations, is that what they have in common is also that it's the plan that they will develop further for each time they'll be updated. A few words about the data that has been used, and when I say data, I here mean the carbon intensity of products that the practitioners will use to make the LCA of their buildings. So we have the EN standard regulating the documentation requirements for the environmental product declarations for construction products, and based on these we have environmental product declarations for specific products or from specific producers, or we have from industry associations, so you would have an industry average of a product. That's quite specific to the ones who paid for the study or the one who publishes it. But when we include it in the regulation in the Nordic countries, we've also had to provide some generic data that practitioners can sort of go to as a representative product. If they don't know which specific product they put in the building, they should use the generic data. And of course, it's a big question of what is the representative product that we should have as a generic product in the database. What is the typical market brick, for instance? So there's a lot of debate about that. In all 3 countries in the regulation, you're able to either use the generic data, or if you know which type of product you have in the building, to use the available EPD. The Finnish and the Swedish authorities, they developed their own generic data, And the Danish system has been, or the Danish building industry has been used to the German data, the Ökobaudat, for so long that it's been really hard to get out of that track. So I think it's in the future plans to develop some more national specific generic data, but for now we're still bound to the German data in Denmark. Okay, this is a bit of a confusing figure. You can always dive into it when you get the handbook, buy the handbook. But this is just to show the benchmarks that we operate with in the 3 Nordic countries here. So reference, limit, and target values. Reference, sort of trying to set the median values for a number of buildings here, offices, single family and multifamily houses. And then the limit and target values that the politicians will try to aim for. And what I wanted to show you here is the difference in calculation rules. So this is just to show, for instance, why the Finnish B6, so that's the operational energy use and the carbon emissions associated with that, it's much larger than the Danish emissions associated with the operational energy use. And that's because in the Danish calculation rules, we include a projection of the carbon reductions of the grid mixes, whereas they don't do that in Finland. It's static values for the whole life cycle of 50 years. So of course that means that the Finnish and the Danish frameworks are really not comparable in that sense either. Then there's also what we can also see from these values here is that from the single family houses, you will find for this single family to the multifamily houses in Sweden, we see a big difference in the sort of the way they are constructed. And that's basically because the single family houses in Sweden are mainly constructed with wood, whereas multifamily houses are constructed with heavy materials. So in this case, the Swedish, when they operate with the limit values and benchmarks, they would have to have it on a granularity where you have benchmarks for single family and for multifamily. Whereas in the Danish case, it was decided that the difference between single family and multifamily was not big enough to have 2 separate limit values. So the limit values that we have introduced for the Danish systems, you can see them here. It's 12 kilograms of CO2 per square meter per year, and that's for all the building types that are in this scheme. And as you can see also from these figures for the Danish offices, single family, multifamily, sort of the median building would easily cope within this limit value. Then there's also a voluntary limit value in the regulation set to sort of drive the industry towards lower emissions from the construction. And of course, they would have to make an effort to reach those limit values. And then there's, I'd like to draw your attention to the budget-based target values. And I know we'll have a presentation about target values and carbon budgets, so we'll probably hear more about that. But this is from another study where the budget-based values were looked into for Finland and for Denmark, and it's just very clear how far the industry has to go to get to that point. So still a lot of work to do. A summary here. So we have quite a lot of coordination going on within the Nordic countries, but still quite limited what they have actually achieved in harmonizing, all with good reasons. So no harm in that. Yeah, and as I mentioned, there are some specific challenges when introducing the limit values. Everything has to be sort of airtight for the number of years that this regulation is in place until it's updated. Then, as I said, this configuration of the method and the data and the benchmarks, it's really it should be airtight and cannot be readily compared with other countries' benchmarks, of course. Then in all 3 countries there will be updates concerning method, concerning process, and also concerning benchmarks, because of course we would need to readjust the benchmark values as soon as we have a readjusted method. And then as we saw, there is a big gap from the current limit values and onto some budget-based values where we take the access point in sort of allowance per user. So preferably this type of per square meter action that the regulatory framework is now driving, we should also have some demand side reductions as on a personal level somehow. Yes, that was the brief intro to Nordic regulation. Open for questions.
Thank you very much, Freya. That was fascinating and really brought out in my mind a question about what the role of researchers should be in developing policy and working that closely to policy. Obviously, it's huge impact, but we only have time really for one question, I'm afraid, and there is one already in the Q&A, which says, Finland and Sweden include Module D. How is Module D reflected in the limit and targets values?
For now,
sorry. Excuse me, the attendee has said, sorry, I meant Finland and Denmark. But anyway, Module D.
Yeah, Module D. For now, it's not included in the limit values in Denmark, but it's reported separately. And the same goes for Finland. So it's not part of the limit values. It's following the European standard and reported separately.
Brilliant, thank you very much. I'm sorry not to ask you the rest of the questions. Yep. There are several in the Q&A. Do answer them.
Yes.
Thank you very much. So our next speaker is Yasmin Dominique Priore from ETH in Zurich in Switzerland. Yasmin, I hope you are with us. Hi, Yasmin.
Yes. Hello. I think you have to give me the rights to share the screen.
I think I have to ask Raman to give you the rights to share the screen, and
I'm doing it.
Thank you very much, Raman.
Second. Here you go.
Perfect. Now make sure that I share the right screen as well.
So now everyone has learned from Thank you.
Okay. I hope you can see my presentation. Yes.
Yes, perfect.
So just 1 second, sorry. Here we are. So hello everybody, and thank you Alice for the introduction. I'm Yasmin Priore, and I'm actually currently doing my PhD at the Chair of Sustainable Construction at ETH Zurich with Guillaume Aber, you heard before, and co-supervised by Thomas Jusselm from the Energy Institute of the University of Applied Science in Fribourg, also in Switzerland. Today I'll present to you the work that we have been doing on global carbon budgets for the built environment, and the question, how far are we then to achieve a 1.5 degree limit in global warming? So, okay. Diving right into the background motivation for this work that is reducing emissions, that is indeed a global goal. You all know very well the Paris Agreement, that of course is an important milestone in the definition of goals to limit global warming. But as you also know, we are still struggling to apply these goals in our society. Net zero emissions, 2 degrees, 1.5 degree are recurring keywords, as you all know, in any climate discussions, in the news, in political agendas, and any conversation lately. But I want to point out, and we have to remember, that reaching net zero per se does not automatically guarantee a specific temperature limit. Reaching net zero in 2100, following this curve, instead of reaching net zero in 2050, following this other curve, will result in this extra and quite enormous amount of emissions that will undoubtedly affect global warming. So the amount of CO2 that we emit till we reach the balance is of extreme relevance. And the studies, and also it was reported in the last IPCC report, show this almost linear relationship between warming and cumulative emissions, meaning that whatever we emit in time will directly affect global warming. So to limit temperature increase to a specific temperature, say 1.5 degree or 2 degrees, we actually have a limited amount of carbon emissions that can still go into the atmosphere. And the IPCC quantified these so-called global carbon budgets in their latest report with a different level of uncertainties. Here I just reported 2 for a 1.5 degree or a 2 degree with a 67% chance of achieving the goal. The question of the research I'm presenting today is how can the built environment understand and align to this global carbon budget? And to try to understand this problematic, we used a top-down approach, and we try to answer intermediate questions to finally understand how and which strategies can help the built environment to reduce emissions, of course, and contribute in this to limit global warming. First, so national emissions. In this case, I use Switzerland as an example, but I do believe that methodologically can be applied to any country. So the emissions at national level are examined first to better understand what is the starting point and which dynamics should a carbon budget and its distribution account for. Then the principles of allocation of a global carbon budget to national level are evaluated and discussed. And then we try to further allocate budgets to lower territorial scales, and we try to understand the limits and hypotheses behind doing such an allocation. Then we took again the Swiss carbon budget and allocated it to sectors. And there we tried to understand how future capabilities of each sector do play a role in this carbon budget allocation. And we finally reached the built environment. We looked into current emissions and how can global carbon budget be then distributed to this broader sector. And then finally, we determined how far our current practices in achieving these budgets, what are the possible strategies and the existing levers that could influence the final result. So looking at national emissions, it has to be mentioned, very important, that emissions reported internationally, this is valid for any country, are based on the territorial concept, meaning that only emissions occurring inside, in this case, Swiss borders, are accounted for. This is the so-called, probably you already know it, the production-based accounting. But what would the situation look like if we actually assume our consumption habits? And as you can see here, in the case of Switzerland, we actually emit 2.5 times more emissions per person. And of course, if we draw a line in reaching net zero, it becomes quite a more challenging goals compared to only looking at production-based emissions. Also to point out in this graph is that net zero goals do not mean that we will 100% eradicate emissions, but more that whatever is left or whatever are considered as inevitable emissions will have to be reabsorbed in some way with possible negative emissions technologies. And here I want to point out in this graph also that we traced the carbon, the natural sink effect that is found in Switzerland, and as you can tell is quite negligible if the goal is to absorb 10 million tons of CO2. And finally, as Switzerland, but as many other countries did, a national strategy to reduce emission was defined, and this strategy does define a linear pathway to net zero, as you can see here in the graph. But in the logic of a carbon budget, this line does not actually mention a limited carbon budget. So cumulative emission that will be emitted if we were to follow this line do not necessarily respond to a 1.5 degree goal. Then how do we translate a global carbon budget to Switzerland? This, of course, raises difficult questions about how best to share these carbon budgets amongst nations in a way that, of course, both respects this need of reducing emissions globally, but also addresses disparities amongst nations with respect especially to historical emissions, but also to their potential future emissions. And in the literature, this question is being debated for different angles and opinions, but 4 main concepts are usually discussed, that is responsibility, capability, equality, and sovereignty. If we think of a fair distribution, this should include all of them, of course, and a balance of environmental effectiveness, equity, national capacity, political feasibility, economic efficiency, and technical requirements should be met. And just to give you an idea of how variable this limited budget can be, one can see here the distribution of 4 different global goals. So we have here in blue 2 1.5 degrees global budgets, so the probability changes, and 2 for 2 degrees in the reddish colors, and distributed to Switzerland with 3 different allocation rules found in the literature. So the equal per capita, taking into account responsibility on past emissions, and the grandfathering concept that basically accounts for the current share of emissions of the country. And in the case of Switzerland, as you can notice, the share of population or the share of current emission doesn't play a big role in the end budget, but of course taking responsibility on past emissions, as you can imagine, because Switzerland is a developed country and contributed largely to emissions in the past, has a great impact in the end budget. And it results even for the 1.5 degree in negative remaining budgets, of course, raising the question on the feasibility of applying such a principle. Therefore, remaining budgets at national level, as you can see, are highly variable, ranging from negative values to positive values, with a difference that corresponds, I just to give you an idea, to 30 years of current levels of emissions. So, of course, choosing just at this level, the principle of allocation will change the conclusions that one can make and the strategies that one would set with such a limited budget. And the distribution of a global budget then to nation is not only, of course, an environmental question, but as you can imagine, is a political and economic debate. And for this reason, we didn't go into this debate, but for further steps in the research, we used the budget for a 1.5 degree goal and distributed to Switzerland with an equal per capita distribution. So the same concept of allocation can be further taken to lower territorial scales, basically applying the same allocation rules. And this can be a useful tool in a way for policymakers to set targets and understand the viable strategies based on, can be in this case, regional or communal differences and situations. But of course, this will also increase uncertainties about these limited budgets and questions about the viability of reducing the scale of analysis. First, the data is less available at lower scales. And second, the disparity that I talked about between direct and indirect emissions, so what is actually emitted inside the borders of the scale you're examining and what is actually imported becomes far more relevant, of course, if you lower the scales. And last but not least, the concept of a carbon balance between sources and sinks is not really consistent if you lower the scale. For all these reasons, we came to the conclusion that reducing the scale to distribute this budget wasn't appropriate for the goal of this research, so we decided to stick to the national level. So the national carbon budget, here in red, can be though further distributed to sectors. And we considered in this case a certain potential of negative emission technologies that will appear in the future, so in the time frame till 2050. And we did consider future capabilities of these sectors to reduce emissions in the same time frame. So, for example, this sector that is called others, this comes from the official report of emissions in Switzerland. It includes agriculture and waste management processes, doesn't actually currently hold such a high share in emissions, but is also estimated that it will not be able to reduce emissions as fast. And thus, if you can see the proportion, it gets quite a high percentage of the budget because we account for the fact that we'll not reduce emissions so much. The same happens for the industry sector, that's in another level, but is also not expected to completely eradicate emissions in the time frame till 2050, and thus gets a higher percentage of the budget compared to the other sectors. In this setting, the built environment, so represented by this house here in the middle, requires a budget for the operation of the buildings. And in the case of Switzerland, the operation of buildings is directly reported as a sector. So what they call buildings is actually the operation of buildings. And a budget for construction activities that we call here embodied budget. And important to notice in this graph, you might have already noticed, is that actually just a quite small share of buildings emissions are actually produced inside Switzerland. Thus, we added an extra budget to account for imported goods that, according to a study conducted by the Federal Office, represents 70% of final greenhouse gas emissions for the construction of a building in Switzerland. And so the embodied budget is basically partially coming from the industry in Switzerland and partially from imported goods. So how far are we in achieving this budget? If we consider the building stock and practices to continue as today, so currently we are at a 1% renovation rate, and we assume that we will follow the current recommendations that are given by, is not a norm in Switzerland, but is a technical recommendations on operational and embodied emissions for buildings. And we also assume that we will continue building new buildings at the same rate as we do today. We can clearly see in these graphs the shaded gray part would be the budget, and the bars behind are the actual emissions till 2050. That we do not meet 1.5 degree budget if we continue the same way. And where mainly we can see that in this upper graph that the existing buildings will basically continue being inefficient and especially reliant on a high share of fossil fuels for heating. That is the case today, and with the conditions set in the model will continue until 2050. And in this scenario, basically, we are saying if we continue like this, we will spend 4 times a limited 1.5 degree budget. So going more towards over 2 degrees, if we were to translate it. Then how could we achieve our goal? That's the other question. And I want just to point out, there is of course not one way of doing it, but the end result is very dependent on many factors that are affecting emissions in the built environment. And here I just present one scenario that would be if we assume that the operation of the stock, the building stock will comply with its budget, and thus here you see it linearly reaching as absolute zero in 2035. And this translates to say that we will decarbonize existing buildings at a rate of 6% per year from now on. Then embodied emissions will follow a decreasing pathway in line with the budget and will result, if we look at emissions per square meter, in 90% less emissions per square meter in 2050. If we consider that buildings that we design today will probably be built in 5, 7, or even 10 years, or at least this is the case in Switzerland, we do realize that we should plan today buildings with already 50% less emissions than the current average to be able to meet the target of 2030 when the building will actually be built. And lastly, if we consider also that production of materials might improve, or hopefully will improve by 2050, there are studies that showed an average improvement in materials production of 40% in terms of kilograms of CO2 equivalent. We can immediately see that if we rely only on this improvement, we will still be far away from the targets in 2050. As I said, there is no one way of meeting the budget. And here I just want to point out that if we do not achieve the big assumption that I did in the previous scenario of reaching zero in the operation of the building stock by 2035, the embodied emissions or budget will have to actually be negative or in a way compensate for the excess emissions that will be emitted. And to end on a colorful note, we created a little interactive parallel coordinate graph that we presented in a conference this year, where we put basically the main levers, so the goal year of implementation, the operational targets, the embodied targets, and the renovation rate. And with this tool, one can basically set or block all the parameters and check how much emission will be spent till 2050, and then compare it to a limited carbon budget. Maybe I'll just accelerate. I think I'm running late. I just took 2 screenshots. It's a very useful tool to understand the dynamics of changing these parameters at building stock level. And one clear example is the 2 graphs here underneath. By just changing basically the renovation rate and increasing it, but without looking at embodied emissions, we actually emit the same amount basically of cumulative emissions till 2050, giving a clear message that just renovating more, but without looking at embodied emissions will not solve the problem. And in conclusion, so defining limited caps on emissions, such as carbon budgets, can be very useful to identify strategies for the wall building stock, but we have to remember the high variability that such budgets have in their background, depending on the allocation rules, as well as the starting hypothesis. In the scenarios I presented today, it is clear that if we don't change anything, we'll have no chance to meet a 1.5 degree budget, but also that given the very hard task to eradicate operational emissions, negative contributions from the building stock must or could be evaluated. And finally, that increasing renovation rate is indeed essential, but only if coupled with very low or if not negative embodied emissions of such renovations. Thank you. Sorry, maybe I took a little bit more.
Yes, that was fine. We are running very slightly late, but it's pretty good. I thought that was really interesting. Thank you so much. We have one question in the Q&A from an attendee who says, does the difference between product-based carbon and consumption-based carbon entail the consumption or lifestyle changes are necessary for actually reducing the carbon? Do they suggest? I think it means that lifestyle changes are necessary. I think that's a good question.
Very good question. Of course, I mean, I would say lifestyle would change both consumption and production-based emissions, actually. Consumption-based emission, what is grasping in contrast to the production-based is whatever is not produced inside the country. So imports, and of course, lifestyle changes would change that, but not only would, yeah.
Yeah.
if that answers the question. I think lifestyle changes would affect emissions in general, not only consumption-based.
Yes, I was going to follow that up too and say your tool looks amazing and very beautiful graphics. Can you type into it? Can you put into it, program into it, no extra construction at all, and see what that comes out as?
Yes, definitely. It's something I want to do. I wanted to do different scenarios on, because now in the tool I set the same rate of new construction as today till 2050. So I wanted to change that, sure, and see the effect.
It would be really interesting. Thank you so much. So I think we're moving straight on to Borja. I think that's right. Is that what you understand, Raman, and indeed Borja?
Yes, Borja is a co-host as well.
Brilliant, thank you. I just saw you made Aoife co-host and I thought, oh no, I think it's Borja next. Borja, you're very welcome. So this is Borja Iziola, who is from the Green Building Council of Spain and is going to talk about life levels, I hope. Thank you, Borja.
Thank you so much, Alice. Let me try and share the screen. Over here.
Yeah, that's looking good, but not full screen.
Yeah.
Perfect.
Now, what about now?
Yep, perfect.
Okay. So thank you very much to all, Rahman, Alice, Jasmine, Freya, all the people who has been before me. It's amazing, so interesting. Thank you very much. Congratulations for arranging this symposium. I will talk very shortly about one of the projects I've been working lately. We have already finished the Life Levels project. And basically, we did a very deep analysis on how regulations, strategies, plans, and methodologies in Europe are helping to achieve decarbonization in buildings. Before that, I need to remember what we already have seen, that we had the COP in Egypt last week, and we know that we are not reducing carbon emissions, but increasing them. A false hope is that we in Europe are the blue line down there, and we are very, very down and even going down, but we are relatively irrelevant for the world. Nevertheless, there are some practices, some regulations, some actions that might be interesting for everyone. Briefly, who's GBC, who are the Green Building Councils, is part of a global network of associations, including all actors of the building sector in each country. Like in the Spanish case, well, they are not the most updated figures, but anyway, about 400 associated members, more than 10 European funded projects, many agreements with many entities. We run an own certification scheme with over 3 million square meters certified. We have a lot of events, and we also run a material platform where we suggest and recommend and give data of several building materials. We have run this project which helped roll out, get to know, and improve the Levels framework. The Levels framework is a voluntary framework. Freya mentioned that in her presentation before, about how to report, how to measure, how to understand sustainability of buildings. There are many countries in Europe, there are many understandings, not just among groups of countries who other countries consider very similar, like the Nordic countries. Of course, for another Nordic people, there is a difference between Denmark, Finland, Switzerland, Sweden, and so on. It is brief, meaning that it comprises 16 indicators, but they are very powerful indicators. And it is called levels because the approach is by level, by entry level. You can apply the levels framework with just your concept design of your building, or you can already have the executive design. You can have all the details and then assess more profoundly. Or you might have already built the project and have real figures and be monitoring the performance of the building. You can also apply the levels framework at that very deep level. With that, I collected things, prepared this chapter of the book. I'm really looking forward to that next year. And I will be presenting briefly now in 3 parts. The first part concerning some important thing about the regulations. A lot of things have happened concerning regulations in Europe, and we mapped them, and it is interesting to see how long it has taken and how deep it has gone. Secondly, I will present a few things concerning the Life Levels project and the levels framework, and those indicators more related to the carbonization. And then, and that is not in the chapter of the book, I will present some graphics that we have been completing lately on the Spanish case, very similarly methodologically as what Yasmin has presented. So this is the general map of what has been happening in Europe since the 1990s and is expected to happen until 2050, when we are supposed to be net zero. Many things influenced from top to down, from the international level up there to the European level, and then also bottom up from the Life Levels project and other projects that we are working in. Briefly, the legend here, what is already approved and adopted, what is still coming, and what is the role of the green building certification systems and other actions which are helping to accomplish this as levering or as creating the landscape for that. You see this enormous landscape, over 50 regulations, strategies, initiatives, and so on. More definitely in the last 10 years, but nevertheless many since the last 20. I will go a bit more into detail in parts. First, until 2014, when basically the levels framework was thought to come to life, then until now, and then more in detail what has been this Life Levels project helping in terms of advocacy and quality of data and methodology. Definitely the Kyoto framework and the Paris Agreement and those big figures, those big targets, which have been increasing in Europe. Some years ago, we were supposed to achieve a reduction in global warming potential of 40% after the Fit for 55 program or package. We have to reduce up to 55%. We had the very relevant EPBD, Energy Performance Building Directive, which has gone through several updates. In the very last update is currently at the Council of Europe to be finally approved. The suggestions were more ambitious than finally the directive will be. And for that, the ministers, basically the energy ministers of the European countries thought that it would not be realistic to apply some of the suggestions that had been proposed before. And many other directives and proposals on renewable energies and so on. In 2015, 2014, the levels framework started when circular economy principles, when more profound debate internationally and at European level started, and when all lights went red concerning the climate emergency. So the idea was then already that Europe would be leading the world in terms of reducing carbon emissions and other climate actions. At times, wording goes faster than facts, but a few things have happened. And it has gone down to many roadmaps for every country, to many long-term strategies for the rehabilitation of the buildings, and that is a big thing in Europe. For many other activities supporting financially, politically, and culturally the renovation, what it is called the renovation wave, linked to a wider circular economy plan and strategy. And lately, with the new European Bauhaus trying to create a new culture for buildings, very different to what building things have been for the last 50 years, and more strategies and plans to come. The Levels framework and then the Life Levels project has helped to understand what is a life cycle perspective, what are the implications of embodied carbon and the difference with operational carbon, what can public bodies do, especially in green public procurement, what is the impact not only on the decarbonization, but on other very relevant indicators which are considered in the Levels framework concerning health, concerning climate adaptation, and so on and so forth. We will look at later. And creating educational tools, calculation tools, regulatory tools, examples, and tenders that help us best practices, other countries, other cities, other projects to develop under this idea of more sustainable, more circular and cleaner buildings. The Life Levels project started in 2019, has just ended with these 8 partners you see there. And we have attempted to make sustainable buildings mainstream in Europe by many actions, with huge dissemination impacts, over 10 million reaches of our press notes, articles, over 230 events, a lot of activity carried out by these 8 associated members, all of them GBCs. You can find some related content to what we are watching in these 2 deliverables, which are open access. If you go later on the presentation, you have the link to them, so that will be easy to download. The Levels framework started timidly and has become, I would say, mainstream. Almost everyone in Europe is listening and is paying attention to what is coming and how the Levels framework is guiding. And although it is a voluntary framework, for instance, if you want to get money from public European funds, you have to report using Levels. So you have to use it, you have to learn it. It comprises 6 macro objectives and 16 indicators. You can use them, you can choose which indicators, how to use them, to which level, at your own will, at your own necessity, depending on what is your building, what is it for, how big it is, how big is your budget, and how big are your environmental and social ambitions. Like, for instance, in blue, you could choose all that macro objective, which has to do with circular economy and life cycle thinking. Or you can go into maybe more standard indicators, which are concerning energy, basically the operational, and the embodied carbon, the global warming potential of the building materials. Or you can go into the other impacts, which are basically considered under life cycle analysis, like a water footprint, quality issues, and also step into resilience, adaptation, and life cycle costing assessment. So many ways to use it, many deep insights when you go deep into the indicators, while at the same time being relatively brief and simple with these 6 objectives and 16 indicators. Again, if you want to go deeper, you can download another deliverable we have done in the project, which helps like a sort of a checklist to address your project, your building, and see how do you use the levels framework. In the Life Levels project, we chose 3 indicators mainly, those related to life cycle assessment, indoor air quality, and life cycle costing, and we did not go deep into the other indicators concerning climate adaptation, or also the very, very important and relevant indicator of the value creation and the risk factors. So finance and value is definitely an issue when studying embodied carbon. We did this firstly by implementing and adapting the levels framework to all the certification schemes run by the 8 partners. This included some partners who did not have a mature system yet to quickly develop it and make all of them levels compliant, meaning that if you certify your building with one of these certification schemes, you already report levels. And that going down into the decarbonization scenarios and budgeting, well, both the IPCC or the International Energy Agency use similar or the same figures. So what we have done in Spain is to reduce again our carbon budget of the residential buildings. So we did not have enough data for non-residential buildings, and we have, of course, left aside other sectors. The International Energy Agency has 2 basic scenarios. One, if countries develop sustainably, and one, if countries aim at really decarbonizing in 2050. And for both scenarios, the figures are very relevant worldwide and at the Spanish proportion. The figures you see down there are the Spanish proportions. We already did something similar to the methodology that Yasmin showed before. What we have gone very much into the detail is what needs to be done. Sorry that this is in Spanish. I will not go into the detail anyhow. What needs to be done by the building sector, meaning manufacturers, public administrations, designers, prescriptors, developers, regulations, everything, if we aim at achieving a net zero or as close as we consider it feasible. So this is the business as usual scenario. We reduce, but we are very far still from the net zero in 2050. We studied another scenario which develops from the best practices of the building sector, and it is more ambitious. It is better. It reduces more, 61%, but of course it's still very far from the expectations. And this is the best practices. Of course, best practices are in the hand of very few pioneers and actors who are very committed to decarbonization and environmental issues or sustainability. Briefly, it intends to reduce embodied carbon to 25%. But it also aims at increasing rehabilitation, basically to double to what is planned, and to use and choose materials with lower carbon. For the rest, and that's not going very much into the detail, what you see in sort of a pink color, the best of the strategies in Spain, should they be implemented. And what we did was the proposed scenario, if we were to achieve, if not the net zero, something very close, passed by a filter of what the actors, and we have had a lot of meetings, a lot of roundtables with over 230 different agencies and more than 900 people to check if they could or they thought feasible to achieve this. And that's where we stopped. If the people do not see it possible, then what are we talking about? They are not going to do it. Even then, this scenario means to reduce the plan, the Spanish national plans for new buildings until 2050 to about half of it. and increase the rate of rehabilitation, basically multiplying by 10 times what is being refurbished nowadays. We aim at achieving for all buildings rehabilitated and new the best energy certification, and to reduce or improve the efficiency of all equipments by 67% and 98%, so almost 100% concerning heating. We also reduce to 30% the embedded carbon in the main building materials, up to 75% reduction of the embodied carbon for those pioneering, meaning that the footprint or the benchmark for buildings would be in 2030, 186 kg of CO2 per square meter in single family houses, 74% in multifamily houses, and in 2050, 66 kg and 26 kg for multifamily buildings. So the challenges, the ambition of this is so extreme, is so disruptive, that although theoretically those attending our meetings who are already the pioneers and the most motivated thought we are really touching what is considered impossible. Even then, we do not reach net zero. And this is the comparison of all that. Basically, what we have done is to a 2 degrees heating scenario in 2050, not to talk about a 1.5 reduction. Some conclusions to finish. Carbon advocacy is possible, even from small groups like the Green Building Councils. Like we are 20 people working here, so we are not a big company. Although we still represent 400 agents, which is less than 1/1000th of the entities in the sector in Spain. But policies help if they are realistic and feasible. If not, they actually can block action. This happens before, I don't know who was it, I think it was Freya, mentioned the European taxonomy. So like for instance, in Spain, some of the targets of the taxonomy are just impossible. So how will we do it? How can we accomplish and respect regulations if they are not realistic? What needs to be done? Europe is actively reducing its carbon footprint. Of course, there is no NATO war in our borders, there is no big oil in the world, and there is no migration from any southern country into Europe. So we are really doing well. As Alice, you are laughing too much. As you mentioned before, independent and transparent and credible data and use of this data are needed to know, compare, and draw conclusions. And hopefully, eventually, they become baselines and benchmarks to be included into policies that help accelerate all these processes. The levels framework is proving useful to support this transition to sustainable and decarbonized buildings, and I do believe so. When I have been giving information on the levels framework, attending or responding to people asking for consultancy, it works. I think it works. And finally, well, finally for now, transition is too soft a term. We are in the midst of an amazing disruption. We need to do things radically different. And one of the very radical different things to do, you also mentioned that in your conclusions, Alice, is to consider if we need to make new buildings. I'm an architect. I was trained to build, not to not build buildings. But we need to do something radically different. And maybe this radical different can have a look at vernacular architecture in each bioregion, in each country, in each county, and see what was done with which materials, how, update it, and basically pay attention to update, refurbish, and use the existing building stock. And in Europe, this is already built. So we have in most countries the buildings that we need. So what we do, we will see in the coming years. Thank you very much. And let's continue. If there are some questions, I'm open to try and answer.
Thank you ever so much, Borja. That was really inspiring and really nice to see a roadmap that might almost get us there, even though you then said that even those tending the meetings thought that this was on the edge and they were already the pioneers. But I was just going to kick off with a first question, that we haven't got time for very many, to say these are radical changes, but this is radical times, and we're all seeing the effects of climate change in our own countries now, not just in other countries. And I wonder if you feel that continued advocacy by people like the Green Building Council, who are not seen as regulators, but are seen as more kind of conveners, you know, one of us, whether you think that will help us to gradually come to terms with what we do need, which is radical.
I do like this word convene and see ourselves as convening partners. 2 weeks ago, I was chairing a table with representatives from the concrete, steel, glass, and also raw earth and wood and vegetal fibers. And they were discussing about the footprints and the footprints of the materials they represented. This does not happen that a guy from the concrete and a lady, in that case, from the raw earth as a basic building material, proved for thousands of years, discuss and come to terms and demonstrate what each material weighs and can do. So convening and sitting at a table with them really changes the view of everyone. And I do think accelerates and creates agreements, and hopefully if the public administrations pay attention, they also adapt. We have some excellent cases in Spain, like for instance, in the Balearic Islands and in Valencia, where the local governments are pushing very much into the bioclimatic architecture and bioconstruction. So yes, I do think it is possible.
Fantastic. That's a very cheery note to end on. Thank you so much, Borja. And I'm really delighted to introduce Aoife Houlihan-Viberg. Aoife, I've never known if it was a V or a W.
It's a Weberg.
Weberg, I beg your pardon, who is Professor of Architecture at Ulster University in Northern Ireland. Aoife.
Okay, yes. Sorry, this is a little bit different than before.
If the share is...
Yes, I've got it. Okay, hopefully this is fine. Yes.
Yes, perfect.
Yes. Okay, so thank you so much, Alice and Raman and Freya and Jeanette, for this invitation to present and share our research. And I've really enjoyed listening to the other presenters, so thank you all so much. So I just wanted, today's presentation is really presenting the findings of our previous research in Annex 57. I'm just going to, how do you, minimize all the participants on the side?
I think you can just sort of...
You could just drag.
It's moved, it's fine. So, yes, so our chapter is called Embodied Emissions Knowledge Building for Industry. And it's really based on the research that we conducted for 5 years in the International Energy Agency Annex 57. So the chapter is together with my colleagues Alice and Freya and Harpa and Tova, and together with my PhD researcher Ben James, who helped us with some fantastic illustrations and helping to make the text more concise. So the basis of the research that we presented in our chapter is based on the results of 80 international case studies. And these case studies were collected from within the Annex participants, but also the academic literature and other technical reports. So the main emphasis really is that these, the findings of our research, we really wanted to make much more accessible, because we're very aware that architects and practitioners won't be reading the published journal papers or many of these technical reports. So we really wanted to improve the impact of our research and help to deliver that into a series of guidelines for designers to follow. So how we did this really was to try to develop and firstly identify what the design strategies were, and to develop a series of simple diagrams and concise text to help support designers in early phase design. So the results that I'll be showing here offer simple, easy to understand communication to help with the knowledge transfer to industry, and also to integrate science-based knowledge into the mainstream. Oops, it's not moving. Okay. So why is it important to consider embodied emissions? Well, you've heard a lot today, but I just wanted to point out that, you know, aside from our own, you know, the research within the Annex 57, we also have the results from our Norwegian ZEB pilot projects. And what we saw there was that as the buildings become more and more highly energy efficient, the contribution from embodied emissions becomes much greater. So what we found in the Norwegian ZEB pilots was this ratio of embodied emissions to operational emissions was in the range of 70 to 30, 60 to 40. And recent IEA Annex 72 results are finding that this burden is actually even increasing. So what we have here, and I'm presenting in the chapter, is the results and output from subtask 4 in Annex 57. So this research was conducted, I can't believe it's almost 10 years when we began that, but still it's very relevant. And what we did was, the purpose of the case studies was to create a collection whereby you know, we could collect these case studies from around the world and extract and analyze the data from, as I said, 80 of these case studies. So we had three main purposes, really. One was to produce, you know, a body of different international case study typologies, and make the building and LCA data easily accessible, transparent, and identifiable. So we published these results in a case study collection report. Secondly, we wanted to use the international case studies to extract and analyze this data so we could do comparative analysis for specific methodological and design aspects. And again, we've published this in another ST4 report. And then finally, we wanted to use these case studies to develop guidelines, which is the focus of this chapter, to reduce embodied emissions and increase knowledge transfer to the industry. And this is published in a simplified guideline for designers. So what we did was, within ST4, we put out a call for case studies across the Annex members, but also, you know, there were cases where data or there weren't case studies available, so we had to then start to trawl through, you know, academic literature and other technical reports. So what we did within the ST4 was to create this case study template. And this was really invaluable to make sure that the data was transparent, and it could also be comparable. So you can see, for example, in slide 2, you know, we use the EN 15978 template, and you would just simply cross you know, which of the system boundaries were included in the case study you were submitting. So the data was submitted to us, the authors, and it could be in a raw data format, or it could be gleaned from published reports and academic literature. So from this, the case study information, we were able to develop a methodological process. And this was developed according to 15978 to analyze the different themes. And secondly, and this is the focus of the chapter, where we were able to identify the design and construction strategies to reduce embodied emissions. So the findings from this research was then published in different formats. It was obviously in the technical reports from the annex, but also it was featured in Alice's book, which she edited, and other journal publications. We also, again, we were very concerned with making the data accessible and making sure, that everything was transparent. So we actually developed a case study code for all the case studies that we developed. And that meant that, you could always trace back to the original case study and the original, the template. So this really helped us to organize the information, start to develop the different themes, and ensure that we could have that transparency that was crucial to our research. So a very big, concern was that, as I said before, a lot of practitioners and architects aren't going to read these detailed technical reports. So how could we facilitate this transfer to industry? And how could we make the knowledge more accessible for designers in the early design phase? So one of the methods, or one of the outputs from our annex, was to develop a sort of a more visual approach in the form of a design guideline, which was aimed specifically at designers and consultants. And what we did was we created, very simple illustrations, as you can see on the right-hand side, and we started to identify those sort of key strategies that work to reduce emissions. And as you can see in the bottom, we always included reference to the original case study. So I just need to move everybody over because I can't see. Yeah. So this is just, a more detailed table where we started to identify different strategies that worked. So what you can see here from the case studies, we could see that there were 4 strategies that really resulted in reduced emissions. So firstly, you had substitution of materials. Secondly, reduction of resource use. Thirdly, reduction of construction stage impacts and the reduction of end-of-life impacts. So in the subsequent slides that I'm going to show now, I'm going to highlight a few of these and go through in more detail. So, for example, the first, in terms of substituting materials for load-bearing structures, for example, what we see is that switching from concrete, steel, and masonry to timber reduced, the weight of the load-bearing construction. And this also helped to reduce the associated embodied emissions. So as you can see on the left, we found some sort of key results for switching from different, concrete, steel, and masonry to timber. Secondly, we looked at the reduction in emissions of switching from brick and masonry to rammed earth. And what we could see is that we had a reduction in emissions, and particularly using rammed earth helped to reduce emissions and increase thermal mass. But however, with every positive, designers need to be really clear that it's not always so straightforward, that there are other impacts that they need to consider, because the effects are very interconnected. So for example, when you switch from brick to rammed earth, then you may also, you would also have a lower thermal performance associated with the rammed earth compared to traditional masonry wall. So often what we also saw was that natural materials require specific design and construction details, and this may necessitate extra protection to be included. So you should always be aware of that when you're switching to a natural material. And we also looked at brick to straw bales, for example, and this resulted in lower emissions. But again, you have to pay attention to those special design considerations needed, for example, moisture and pest protection. So for non-load bearing structures, for example, we found that insulation was a very important material to look at because of, the large parts of the thermal envelope, which are made of insulation. So this has quite a large potential for reducing emissions, particularly if you switch from mineral wool to a wood wool or a wood fiber insulation. Another strategy we uncovered was that it's a good approach to switch from aluminium curtain walling, for example, to timber curtain walling, because often the aluminium curtain walling is made of metal, particularly aluminium, which can have a sort of a shorter lifespan and high material processing. So switching to timber, we found was a very good strategy. And this is something that was also used in the Norwegian MZ pilots. And I can go on to that later, where we used a sort of a Japanese technique to char the outside and seal the outside of the wood cladding. And finally, then switching from cement to clay. Replacing cement-based plasters with clay plaster was a simple way to reduce emissions. Another benefit is the clay is locally sourced and it helped to balance humidity indoors. But again, you have to be aware that there may be impacts to consider in terms of durability and lifespan of the clay. So in terms of reuse and recycling of materials, we identified 3 strategies. One was the recycling of brick. And obviously this has a beneficial impact in the sense that you're not using new materials. So obviously you're saving emissions by using the recycled brick. But we actually found that the reductions were quite negligible, at least in the cradle to gate stage, particularly because the materials often needed, additional virgin materials to be added to give the material more strength. And also you would need to pay attention to transport emissions and where the source of the recycled brick was coming from. In terms of upcycling waste, the emissions reductions were quite considerable for using upcycled materials, but again, you had to really pay attention to the quality of the waste materials and their structural integrity, and also the availability of this material from recycling facilities. So finally, when you come to recycling of concrete, again, like brick, it is favorable in the sense that you're using less new materials. But you need to really pay attention to, the virgin materials that need to be added to the concrete. If it is, for example, to be reused, you need to pay attention to the amount of energy that's needed, to crush the concrete, for example. And also in terms of even if you were to use, more greener concrete, you need to pay attention to the fly ash that's used, So, for example, in Norway, there is no coal-fired power station. So actually that fly ash has to be imported from elsewhere. So that also is something to be to pay attention to. I don't know how I'm doing time-wise, but
You're about
am I okay?
You've not got a great deal of time left, Eva.
Yeah, no, okay. Well, I probably won't get through all the strategies, and I think I'll just probably move on, but they're all here so we can look at those afterwards. But I'll just finish up really. So, you know, there's so much importance in really taking our research, even where we are today, and looking at how we can sort of visually communicate this in a way that's more accessible to practitioners, because they are the ones that really are really looking to us for developing guidelines, offering advice on what should they do in terms of their design strategies to reduce emissions. So what I have shown in the presentation today is that, you know, we have identified a lot of key design strategies, but we need to make it very clear what those interconnections are, and we need to communicate that in a very clear and accessible way to building designers, because we really need to make sure that they can optimize and prioritize key design decisions that are actually going to reduce emissions. So the first thing would be, you know, to be aware that, you know, of this high interconnection, that, you know, just switching from, you know, steel to timber, it's not as simple as that. You know, you need to be aware of those positive and negative impacts. And it would be really useful for us to start to develop open source, transparent, robust and reliable case study databases that architects and other practitioners could really look to and start to understand those design strategies they could take. And also we need to look at further research in, you know, how do we apply this knowledge to practice? And even from what we've done so far, does it actually, is it actually resulting in impacts to reduce emissions? So I think I'll just end up there. Yes.
Perfect. Thank you very much, Eva. That was beautifully reduced at the end. That was really nice. Thank you very much. I don't know that we have any questions in Q&A, and it's quite hard for me to ask a question because obviously I know the project.
Yeah.
But I was going to say, do you think that, I know you worked as an architect just as I worked as a structural engineer before we both moved into research, do you think that really helps with doing this very industry focused research?
Yes. I think it's actually invaluable to have a foot in both camps almost, because I find, you know, when you're in the annex research, for example, having that hat of the architect is really invaluable. But conversely, I find, you know, in studio, or even when we're trying to communicate these key findings to, you know, business leaders, you know, it's really important to understand the science, but find ways that we can distill it down and communicate it in a more visual way. So that's actually an area that I'm finding is more and more important, because especially, you know, for the architects in studio, and, you know, they're the practitioners of the future, and they are hungry for knowledge. But like I identified in our research, I mean, they don't find it that easy to understand our technical reports. So the more that we can sort of have this dissemination part to our research in all aspects, is going to be really important to deliver real reductions.
I absolutely agree. Thank you, Raman. You posted in our chat